पुढचा पॉइंट यामध्ये आपण बघूया, थेअरी ऑफ ओरिएंटेशन अँड रिॲक्टिव्हिटी. म्हणजे यामध्ये आपण काय स्टडी करणार आहोत? ऍक्च्युअली व्हॉट इज द रिझन why that three category causes orientation at different position, why there is a decrease and increase in the reactivity, हे यामध्ये आपण स्टडी करणार आहोत. And here I am going to explain that orientation and reactivity on two different modes or two different bases. One is the explanation based on the nature of reactant, and that is substituted benzene. What is the nature of substituted benzene? What is the nature of reactant? This is the first mode for the explanation. And second mode, explanation based on the uranium ion intermediate. What is the nature? What is the stability of uranium ion? On that basis, we can explain about that orientation and reactivity, second mode. And we know that there are three main categories, groups, which are already present on the aromatic ring. First one is the ortho and para-directing group with activation. Second, meta-directing group with deactivation. And third, ortho and para-directing groups with deactivation. First mode, actually, it is based on the nature of reactant. Okay. Now let us see first category, ortho and para-directing groups with activation. Why these are the activating groups? Why the electrophile attacks at ortho and para position? हे आपण बघणार आहोत. Consider the example. Okay. OH, NH2, NHR. Okay. Then SH. These are the example. Means atoms are group which having lone pair of electrons. This group having lone pair of electron. Therefore, that OH group having plus M effect. There is electron donating mesomeric effect. आपण स्टडी करणार आहोत why that phenol causes electrophilic substitution towards ortho and para position. Why there is electrophilic substitution at ortho and para position, and also about the reactivity of that phenol. Now, in the phenol, substituent is the OH, and it belongs to the first category. There is a lone pair of electron on the OH, and it causes plus M effect. That is electron donating mesomeric effect. Now let us see how that OH shows electron donating mesomeric effect. And this OH can donate this electron pair towards aromatic ring. Suppose this electron pair form a pi bond between oxygen and aromatic carbon. It forms a pi bond between that aromatic carbon and oxygen. Therefore, to maintain the valency of that aromatic carbon, इथं असणारा जो carbon आहे, to maintain the valency of this carbon, one of the pi bond undergo breaking, and this electron pair goes on the next carbon, and thus we get the canonical structure, we get the resonating structure for the phenol. Okay, and this is the resonating structure. Here, that oxygen donates its electron pair. There is a formation of double bond. Therefore, oxygen acquire positive charge. There is a positive charge on the OH oxygen. Next carbon. This carbon acquire negative charge. Because this pi bonded electron pair goes on the next carbon. Therefore, it acquires negative charge. There is a negative charge. Okay, this is the first structure, canonical structure, mesomeric structure for the phenol. Now, this negative charge means there is an electron pair. Now, this electron pair again undergo delocalization. It delocalizes in the benzene ring. Now let us see how it undergo delocalization. It form a pi bond between these two aromatic carbon. It form here pi bond. Now to maintain the valency, that pi bond undergo breaking. Electron pair goes on the next carbon and it acquires negative charge. Now there is a negative charge, and here there is a new pi bond. Okay, thus there is the formation of another canonical structure for the phenol. Now it having pi bond in the new position, while that para-aromatic carbon having negative charge. Negative charge means again there is electron pair. This electron pair again undergo delocalization. There is delocalization. It forms pi bond between next two carbon. Therefore, next pi bond undergo breaking, and it forms a negative charge on the another carbon. And thus there is this carbon now acquires negative charge, and thus OH group, hydroxy group, is having electron donating mesomeric effect. It donates its electron pair towards benzene ring, and this electron pair delocalizes in the benzene ring, and we get number of canonical structure. Now, what should be the statement from that canonical structure? That canonical structures, that resonating structures of phenol shows that there is a negative charge on the ortho position, then para position, and also on the another ortho position. Means to ortho position, and one para position having negative charge, means there is a more electron density. There is a more electron density, means we can say that ortho and para positions are electron rich. That positions are electron rich, and therefore electrophile, we know that electrophile is positively charged. Electrophile is positively charged, and that electrophile can be easily attacked on the ortho and para position, because that positions having negative charge, that positions are electron rich, and thus that phenol undergoes electrophilic substitution at ortho and para position. Okay, this is the reason why the phenol undergo electrophilic substitution at ortho and para. Now, similar to phenol, all the another atoms are grouped. For example, NH2, NHR, SH. Okay, all that atoms are grouped which having lone pair of electron, which having plus M effect, which having electron donating mesomeric effect. They show ortho and para electrophilic substitution, means that groups are called ortho and para directing groups. Then what's about the reactivity? Actually, we know that these atoms are grouped, donate its electron pair to the ring. Ring कडे ते स्वतःची electron pair देतात, and therefore electron density of the benzene ring, electron density of the aromatic ring increases, and therefore electrophile easily attack on that ring, and thus we can say that it is more reactive. Phenol is more reactive towards electrophilic substitution than benzene itself. Thus, that groups are activating group. It increases the reactivity of electrophilic substitution. म्हणून या ग्रुपला आपण काय म्हणतोय? Ortho and para directing group with activation. They increases the reactivity of electrophilic substitution, particularly phenol, aniline, and all of these compounds which having plus M effect. All the remaining atoms are grouped except the alkyl group. They show the plus M effect. Therefore, they are ortho and para directing. Therefore, they causes activation. No doubt about that. But what's about the alkyl group? What's about the alkyl group? They do not having plus M effect. Then why they are ortho and para directing? Okay, let us see explanation about that also. That's an explanation we put out. Why the alkyl groups, if present on the benzene, they causes ortho and para electrophilic attack. Let us see simple example of alkyl group. Suppose this is the CS3 methyl group which is present on the benzene. This is called methyl benzene, किंवा simply आपण याला toluene असं म्हणतो. This toluene shows hyperconjugation effect. What is the hyperconjugation effect? There is a release of electron from the CH bond towards conjugated system. म्हणजे CH bond मधले electrons release होतात, and they are delocalized in the conjugated system, and we get number of contributing structure, and that concept is called hyperconjugation. Now let us see how this toluene shows hyperconjugation. In between carbon and hydrogen, there is a covalent bond. Actually, this bond undergo breaking, and this electron pair goes in between carbon and aromatic ring. There is formation of new pi bond here. Now, to maintain the valency, this pi bond which is present in the aromatic ring, this pi bond undergo breaking, and this electron pair goes on the next carbon. Here this is the new pi bond, here this is the new pi bond. Okay, now there is hydrogen, that hydrogen having positive charge, while this electron pair goes on the next carbon and it acquires negative charge. Okay, and this is called hyperconjugation. याला आपण hyperconjugation असं म्हणतो आहोत. The release of electron from the CH bond, they are delocalized in the benzene ring, they are delocalized in the conjugated system, and this is called hyperconjugation. Now that carbon having negative charge means there is an electron pair. Now similar to resonance effect, here this electron pair also undergo delocalization. It forms a pi bond between next two carbon, very similar to the resonance effect. And therefore, next pi bond undergo breaking, and electron pair goes on the next carbon, and we get the here H plus as it is. Now there is a no bond between carbon and hydrogen. This is the new pi bond. While there is a negative charge on the para position, now there is electron pair, again undergo delocalization, form a pi bond here. Therefore, next pi bond undergo breaking, electron pair goes on the next carbon. Now it acquires negative charge. Okay, this is the new bond actually. Here, formation of new bond, while this carbon acquires negative charge, and we get the hyperconjugation structure for the toluene. Similar to that first CH bond, that second CH bond also undergo breaking. We get same type of three structure. Due to release of first CH bond, we get three structure. Hyperconjugation structure. Similar to second CH bond, we get three more structure. Similar to that, suppose third CH bond undergo breaking, again we get three structure. And thus totally there are 9 possible hyperconjugation structure for toluene. That hyperconjugation structure also having negative charge on the ortho position, negative charge on the para position, negative charge on the ortho position. That ortho and para positions are having negative charge, and therefore here also electrophile attacks on the ortho and para position, and it undergoes electrophilic substitution at ortho and para position, and thus all the alkyl groups, they are ortho and para directing. Alkyl group which shows hyperconjugation effect. Now, what's about the activation? What's about the reactivity of benzene ring? Due to release of CH bonded electron, that electrons are delocalized in the benzene ring. म्हणजे CH bond break होतो आणि त्यामधले electrons कुठे जातात? They goes towards aromatic ring, and therefore electron density on the benzene ring increases, and therefore electrophile easily attack on the ring, and thus there is an activation. There is an increase in the reactivity of benzene ring towards electrophilic substitution. Okay, this is just about the orientation as well as activation. Now let us see explanation about the meta-directing group with deactivation. What are the examples of this group? Yes, NO2, then NR3, then also CN cyano group, very important functional group, then CHO, then ketone, carboxylic group, ester, amide, then sulfonic group, CCl3, CF3. These are the atoms or group which causes attack of electrophile at meta position. Means these groups are meta directing. Now let us see why that atoms or group are meta directing. आपण ते बघणार आहोत with the help of their resonating structure. They are having minus M effect. Consider the example of, very simple example of nitrobenzene. Here this is benzene ring. It is attached to nitro group, and there is double bond O and oxygen having negative charge, nitrogen having positive charge. This is the nature of nitro group actually. Okay, this is nitrobenzene. Now in this nitrobenzene, nitro group having minus M effect. It having electron withdrawing mesomeric effect. Means what happens here? It withdraws electron from the benzene ring. म्हणजे काय होतं फर्स्ट स्टेप मध्ये? हिअर दिस बॉन्ड अंडरगो ब्रेकिंग अँड दॅट इलेक्ट्रॉन पेअर गोज टुवर्ड्स नायट्रोजन, आणि त्यामुळे इथला पाय बॉन्ड ब्रेक होतो आणि ही इलेक्ट्रॉन पेअर जाते ऑक्सिजन कडे. ऑक्सिजन ॲक्वायर्स निगेटिव्ह चार्ज आणि ही इथला पाय बॉन्ड शिफ्ट होतोय इन बिटवीन नायट्रोजन अँड अरोमॅटिक रिंग. व्हाईल व्हॉट्स अबाउट दिस कार्बन? या कार्बनवर कसा चार्ज येईल? हिअर ड्युरिंग शिफ्टिंग ऑफ पाय बॉन्ड electron pair goes away from this aromatic carbon. Therefore, this carbon acquire positive charge, and we get the canonical structure. Here there is a negative charge on the oxygen. Here single bond, double bond nitrogen, and this carbon acquire positive charge. Now again a delocalization is there. Actually, that aromatic carbon having positive charge means it is electron deficient carbon. Therefore, this next pi bond, this pi bond shifted towards that electron deficient carbon. हा pi bond म्हणजे यामध्ये असणारी electron pair, it shifted towards that electron deficient carbon, and here there is formation of new pi bond. Here there is formation of new pi bond, and we get the another structure. This is the new pi bond shifted. इथला pi bond इथे shift होतो towards electron deficient carbon. Here this is the new pi bond. While what's about this carbon of para position? Now this carbon acquire positive charge. इथं पॉझिटिव्ह चार्ज येतो. पुन्हा एकदा पॉझिटिव्ह चार्ज means electron deficient carbon. Therefore, this pi bond shifted towards that electron deficient carbon. While now it acquires positive charge, and we get another canonical structure. Here there is a positive charge. Okay, thus nitrobenzene shows electron withdrawing mesomeric effect, and we get number of canonical structure. We get number of resonating structure. Okay, this is just about the resonance effect. Now let us see about the electrophilic substitution. Now what's about the common statement? Yes, in the resonating structure of nitrobenzene, we have seen that there is a positive charge on the ortho position. there is a positive charge on the 2 ortho position as well as positive charge on the para position. And therefore, what's about the electrophilic substitution? What's about the electrophilic attack? Is it attack on the ortho position? Electrophile already positively charged, and ortho and para position are electron deficient. They're having positive charge. Therefore, electrophile do not attack at the ortho and para position. But what's about the meta? What's about the meta? Meta position do not having positive charge. Means they are comparatively electron rich, and hence electrophile attack on the benzene at meta position. Similar to nitro group, all the remaining atoms are group. For example, NR3, then CN, CHO, COR, COOH, all these are having minus M effect, and therefore they are also meta directing group. Now what's about the reactivity? Here nitro group withdraws electron. Nitro group withdraws electron from the benzene ring, and therefore electron density of the benzene decreases, and hence electrophilic attack, the possibility of electrophilic attack also decreases. Means there is a decrease in the reactivity towards electrophilic substitution, and thus there is a deactivation due to minus M effect. The overall electron density on the aromatic ring decreases, and which result in the deactivation of ring towards electrophilic substitution. Okay, this is the second category. First category is the ortho and para directing with activation. This is the meta directing with deactivation. And let us see third category. These groups are ortho and para directing, but there is a deactivation. And examples of such group is halogen, chlorine, bromine, iodine, fluorine. These are the examples of such group. Actually, consider the example of chlorobenzene. Suppose the substituent present on the benzene is a chlorine. Here that halogen having a lone pair of electron, and it having tendency to donate this electron pair towards benzene ring, towards conjugated system. Therefore, it also having plus M effect. Similar to the another atom or group, for example, OH, NH2, that chlorine also having tendency to donate this electron pair towards aromatic ring, means it shows plus M effect. Now let us see how it shows plus M effect. This electron pair donates towards benzene ring, it form pi bond, therefore next pi bond undergo breaking, electron pair goes on the next carbon. We get the canonical structures. Again it undergo delocalization, that's a puna delocalization hota. We get another canonical structure. Here there is a negative charge, it again undergo delocalization. We get one more canonical structure. Here there is a negative charge, and thus lone pair of electron from the chlorine delocalize in the benzene ring, and we get number of canonical structure, we get number of resonating structure for the chlorobenzene. Now what's about the statement regarding chlorobenzene? In a chlorobenzene, the ortho position having negative charge similar to phenol, then para position having negative charge similar to phenol, and another ortho position also having negative charge. Means two ortho position and one para position having negative charge, means there is a more electron density at ortho and para position. Therefore, electrophile attacks on the chlorobenzene at ortho and para position, and it undergoes electrophilic substitution at ortho and para position. Thus, chlorine is a ortho and para directing. This is about orientation. But what's about the deactivation? Chlorine is comparatively more electronegative atom. It is more electronegative atom than carbon. There is a covalent bond between that chlorine and this aromatic carbon. And this chlorine is more electronegative, and therefore it withdraws this bonded electron pair towards itself. या बॉन्ड मध्ये असणारी जी इलेक्ट्रॉन पेअर आहे तो क्लोरीन काय करतो, स्वतःकडे ओढतो. मग ही इलेक्ट्रॉन पेअर इथं वळतो, therefore it becomes electron deficient. त्यामुळे या बॉन्ड मधली इलेक्ट्रॉन पेअर त्याकडे ओढतो, इथल्या बॉन्ड मधली इलेक्ट्रॉन पेअर त्याकडे ओढतो. मीन्स there is a inductive effect, there is a minus I effect. Chlorine having minus I effect. Chlorine having minus I effect. So we can simply say that chlorine having strong minus I effect. There is a strong electron withdrawing inductive effect. And due to that, the overall electron density on the benzene ring decreases. त्यामुळे benzene ring वर असणारी electron density इवन दो देर इज अ प्लस एम इफेक्ट, जरी त्या ठिकाणी प्लस एम इफेक्ट असला, प्लस एम म्हणजे काय, क्लोरीन शोज टू इफेक्ट. One is the plus M, electron donating mesomeric effect. It donates its electron pair towards ring. This is plus M effect. But exactly reverse, it having minus I effect. त्याकडे मायनस आय इफेक्ट आहे. इलेक्ट्रॉन विड्रॉइंग इंडक्टिव्ह इफेक्ट, इट हॅव्हिंग इलेक्ट्रॉन विड्रॉइंग इंडक्टिव्ह इफेक्ट. मग त्यामुळे काय होतं, हिअर दॅट क्लोरीन इट विड्रॉज दॅट इलेक्ट्रॉन टुवर्ड्स इटसेल्फ and therefore electron density on the benzene ring decreases. म्हणून त्यावरची इलेक्ट्रॉन डेन्सिटी बेन्झीन रिंग वरती कमी होते. and hence reactivity of benzene ring towards the electrophilic substitution also decreases. म्हणून रिएक्टिव्हिटी सुद्धा थोडी कमी होते नॉर्मल बेन्झीन पेक्षा. and this is called deactivation. and thus halogen deactivate the benzene ring towards electrophilic substitution. And thus we have studied the three categories. One is the ortho and para directing with activation. Second category मध्ये आपण beta directing groups and how they causes deactivation आपण स्टडी केलं होतं. आणि थर्ड कॅटेगरी ortho and para directing but there is a deactivation. Example is the halogen. Okay, this is just about the explanation regarding the orientation and reactivity on the basis of nature of reactant, nature of monosubstituted benzene.